our third problem on the series of recursion. So we've already done 2 questions. If you have not checked out those videos, I would highly recommend to do that, right? And today we are going to discuss the third question in this video. First, we'll take a look at the problem statement. Then we'll figure out an optimized way to solve the problem, followed by the implementation of the algorithm that we discuss. Okay. So let's take a look at the problem statement. The problem statement says that you have been given a string S and you need to find all possible combinations of the string that is possible by following the same order of characters as given in the string S. Okay. So what it tries to indirectly say is, given an input string S, you need to find all of its permutations. Okay. So this question is about permutations, right? So what does permutations mean is that you have been given a string, you need to rearrange the characters of the string in no matter or however ordering you want, right? And based on that, you have to basically find out all the possible arrangements of the characters. So for a given input string ABC, in the output, we will obviously have the input string again. Then we can have A, C, and B, in which a B and a C has been swapped. And then we have a BAC, BCA, CBA, and CAB. Okay, so I think the problem statement is pretty simple. Given input string, you have to find out all the permutations of the given input string. Okay, so now let me drill down the given input situation a little bit more. So if the given input is ABC, you have first the input again, okay? Then you have this and this swapped. So you have this, okay? And then let's say you have this and this swapped, which is BAC, okay? Now with BAC, if I swap this again, so this will give me BCA, right? And then if in the original string I swap these two, so I will get C, B, and A. And then I will have C, A, and B. So total, we can see there are 6 strings in the output. So for a given input string, which is of length 3, right? The total number of permutations over here is 6, correct? Let me take another example. So if I just take the string AB, in that case, the output will be simply AB and BA, correct? Nothing more than that. So I can see when the length of the string is 2, the number of permutations are 2. Okay. To generalize the concept a little bit more, I will take one more example. So if the length of the string is, let's say, 4, and we have A, B, C, and D, let's see all the possible permutations. First is A, B, C, D only. Then we have A, B, D, and C. Then third we have A, C, or rather let's first take A, D, C, and B, and A, D, B, and C. Okay. And then we can also have A, let's say C over here. Then we have B, D, and A, C, D, B, and so on, right? So in these permutations, the A was always at the front, right? Similarly, if you will keep B on the front, then I think again, these all sorts of permutations will come, okay? So if you will have a string of length this, think of it this way. These are all the permutations when the A is at the front, right? And that is 6 permutations. Then I will keep B at the front and again 6 permutations, right? Then I will keep C at the front and 6 permutations. Then I will keep D at the front and again 6 permutations. So a total of 24 permutations. So if I try to generalize the concept, can I say that for 3 it was 6, for 2 it was 2, for 4 it was 24. So that means that for a given input string of length n, the total number of permutations for that string is going to be n factorial, correct? Because 2 factorial is 2, 3 factorial is 6, and 4 factorial is 24. So I can say for a given input string of n characters, total number of permutations is n factorial, and that we have seen from the proof here as well. Okay, so these kind of observations are again very important because it helps to define the overall flow for the problem and how I would say indirectly you are going to approach the solution as well. Okay, now remember, you have to solve this question using recursion, right? So you will have to make use of some property of recursion over here to solve this question. Apart from the fact that we have n factorial permutations for a given input string n, another thing to notice here is literally all permutations are in some way a swapping of the characters, correct? This permutation, if you have to come here, this is nothing but a swapping of this and this, correct? From here, if you have to come here, that is nothing but a swap of characters. Here, let's say these two are here, and indirectly you can say that DC came here and D come here. So there is some kind of rearrangement happening over here to basically find out the final answer. Okay, again you can see if I have this, A and D was fixed and only these two are swapped. So from one permutation you can always go to another permutation by just doing a simple swapping of the characters. Okay, remember that. And that is going to be, I would say, the heart of this solution as well whenever you are trying to find the permutations. Okay, so what we will do is we will take an input string A, B and C. Okay, we'll start with a input string which is having 3 characters, right? And then we're going to do something like this. So this is kind of like a recursion tree structure for this. So first, remember that at this position, right, I can have any of the 3 characters, correct? I can either have a, I can either have a B, or I can either have a C. For this character, if this character is fixed, right, let's say I picked a particular character and put it here. So if I'm putting a particular character here, then for this position, I have only 2 choices, correct? If in the first position, I put a, then for second position, I can either put a B or I can either put a C. If in the first position, I put a C over here, then in the next position, I can either put a or a B. So there is only 2 possibilities. And when there are 2 characters fixed, for the last character, you only have 1 possible position. And that also gives you the answer 3 into 2 into 1, which is 6. Okay, so another thing to note over here. So what we'll do is we'll start with each and every position one by one and make our way down from there. So we'll first talk about the very first position. Okay, so for the very first position, I can keep and for placing the elements as a position, I will again use the swapping operation. So the first operation is that the first character is swapped with the very first character. So here I am swapping A with A. Okay, this will become more clear as we move down the tree. Okay, so if that happens, then this is the A over here, and then B and C. Those remain same since we are not touching. Another possibility is that you basically swap A with a B. Okay, because I told you that permutations are nothing but a swap. So if that happens, then a B comes at this position, okay, and then A and C. The third possibility here is that you swap A and a C. Okay, so if that happens, we can say that A will not be here anymore. At the first position, you will have A, then B and A. Okay, so for the first position, we have figured out all the possibilities over here. All right. Okay. Now next, what we are going to do is, once this position is fixed, now we are going to talk about this position. Let me also write down what we are doing. So we are swapping A with a B, and then we are swapping A with a C over here. Now this position is fixed, okay, and we have to work on the next position. So for this position, either B will remain at its own position, so I will have again this, or I can swap a B with a C, okay, because there are only 2 options I told you for the second position, as you can see. So here I will have A, C and B. Okay. Now for this position also, the B is fixed. Now you have to place for this position. Now for this position again, either A stays at its position. So this will be this. And for this, I can either swap a A with a C. So this will give me this. Okay. Now again for this position also, the C is fixed and I have either I place B at its own position or I swap a B with a A. So that will give me C, A, B. Okay. Now for the last level, we don't really have to do much here because if these two positions are fixed, okay, and if I have to work out for this last position, there is no option. Like always, there is one possibility only to do this, right? Because there is nothing else to swap it with, because at this position, if the first two characters are fixed, there is only one possibility to do over here. So we don't have to like go down here. The answers at this level are the final answer. And you can see that these are nothing but the base cases as well. Correct? Because you have no more characters left after this. Right? So what we'll be doing is we'll be iterating the tree in such a way that first we'll fix the position A. One second. We will fix the position A. Okay. And then we will go forward to find out the answer what happens when we try to put the second character. Okay. For third it's same. Then so it's basically like this. We are going here and then we are going here. Okay. Once we are done with this, that we have find out an answer, we are going to swap back. Okay. So the B was swapped with B only. So there's nothing happened. So when we swap back also, it's the same position. Now the B and the C will be swapped and this is what you get in the output. Once you're done with this output, you're going to go back and swap back the swapping operation that you did. Okay. So B and C are swapped back to their original position now. Once you're done with this, you will go back. Okay. And then you'll come down again. And here, now we are again at the very first position. So we have with A. Okay. And now we'll do the operation of swapping A, right, with B, because that is what happens. So we'll get this and then we'll move here with this for the second position. And then we will come back, go down again, do for this operation, undo the swap operation. So this is undoing the swap. First we are doing the swap and then we are undoing the swap. And then we come back. Okay. And then for the last position, we swap an A with a C and we drill down for the second position as well. And then we undo this swap, then we do another swap with other position, come back, come back. So this is in turn what the actual flow is for this entire problem. All right. And that is what will define the solution for this problem as well. So I hope this tree gives you a good idea of what we are trying to do here. Okay. I remember telling you all this and I'll repeat it again, that the entire essence of permutations is swapping. How do you do the right swap, right? By keeping some characters fixed and some positions characters variable, and then find out how you can solve this. So this will help you to understand how the operations are working. And again, we are doing everything we do in a recursion thing, right? I'll repeat it once again. For every recursive question, you have to have a base case, which we have. These are nothing when you have no more characters left in the string, which can actually be shifted. That's a base case. You have to do some self work. Here the self work is nothing but the swapping operation, right? And then we are putting recursive calls. So it's more or less saying that I just give me the answer for the permutation of BC, right? And I will just add myself in positions between, right? So if BC permutations you got is what? B and C and C and B, right? If you have to add a between to it, right? What you can do it, you can add a at this position. So let's consider each and every permutation. So let's say you have this permutation. Okay. If you have to add a additional a permutation to it, you can add either a over here, or you can add a over here, or you can add a over here. Correct? So ABC, BAC and BCA. Similarly, from the smaller solution, you got CB. Now using CB, if you have to find the permutation of ABC, once you will add it over here, once you will add it over here, and once you will add it over here. Okay. So that is another way to think about it. All right. The above solution is more or less like a backtracking solution. Okay. So if you know about backtracking, you will be able to relate to this concept, right? Where what we are doing is we are doing something, which is the swap operation. Then we are basically doing, let's say, a recursive operation. And then we are undoing that operation to find the other answer. But if you want to look at a basic recursive approach, that is what also you can do. You want to form the answer for ABC for finding all of its permutation. Here, the smaller problem is BC. So you try to form the permutation for BC, and using those permutations, all the permutations for BC, you're trying to form the permutations of ABC, which is nothing but adding A at different positions. All right, here also you can see. So I hope this helps you to understand what exactly is the overall idea. Feel free to use any approaches you want. In this case, how will the recursive call works is, you will call for ABC. Now for ABC, the smaller problem will be to find the permutations for BC. The smaller permutations for BC will give the smaller problem task to C, and then to an empty string. For an empty string, there is no permutation, so you'll just get this. For C, for a single character, the permutation is just that character, so you'll return this. Now, using the permutation of C, you have to form the permutations of BC. So here what we will do is, for C, we will add it once over here, and another time we will add it over here. So one time we are adding at the back, and then we are adding at the front. Now we will return this answer to another problem, and we using this, we have to form the permutation of A, B and C. And what would that be? For BC, remember, if you have a string of length 2, there are 3 possible positions where characters can be added, correct? One time it can be added over here, in between, or in the end. Okay. Similarly, when you have CB, then one time the character can be added over here. One time the character can be added over here, and one time it can be added over here. Now think of this way. Let's say using this, you had to form the permutation. Let's say it was one level above. You basically did this. Like for forming the permutations of DA, BC, you called this. Okay. Now this all result will be provided over here, which will be ABC, BAC, BCA, ACB, CAB, and CBA. Now using this, you have to form the answer for DABC. Okay. So again, the same thing. What I will do is, I will take the first output, which is A, B, and C. And since here we have 3 characters, so the total positions where another character added is 1, 2, 3, and 4. So I will add a D over here once, I will add over D over here once, and then I will add over D here once. Okay. Similarly, I'll show for one more. We'll take the second output for the smaller call now, which was BAC. Okay. And then I will add D at all possible positions. And these are 8 outputs of these. So 4 outputs from here, 4 from here, 4 from here. So a total of 24 outputs. Correct? So feel free to implement whatever approach you are comfortable with. I will show you the implementation for one of these approaches. Okay? So let's take a look. Alright, so now what we'll do is, we'll take a look at the implementation for this problem. Okay, so how does that work is, we will make a function get permutations, and let's say we are calling it for A comma B comma C, and whatever the output for this is, I am doing console.log, and I'm doing this. So whatever output is, I'll get it. So now I am implementing the second approach, okay, which was the more simplest approach, where we are, just getting the answer for the smaller case and then using that to build the answer for the bigger problem by adding the elements at all the position. So it goes by the same name, okay, and then we are passing the string to it. Now the base case is that if the string dot length is equal to 0, Okay, then I am, let's say, returning all the permutations in an array. So I will just simply push an empty string to it, right, and then I will return that array. So this will be my base case, correct? Now next what we are going to do is we will take the first character. And how do we get the first character of a string? This is basically str.char@0. Okay, then after that, what is the rest of the string? So if ABC is taken and if I remove A, so that is going to go in CH. If I need BC, if I need that, I do this. Okay, so now this is having A and this is having BC, which is our smaller problem as well. So what I'll do is I will store the recursion result or the result for the smaller problem when I pass ROS to it. Now ROS is basically containing this BC and CA, correct? Don't bother about what is happening at the lower level at a smaller problem. Just bother about the fact that you are handling all the three things: base case, self work and recursive call. So far we have done base case, we have done recursive call. Now only the self work is left. So once you get the recursion result, you try to use that and build your own result, and in the end you just return it, correct? What you do in between is you iterate over all the results of the smaller problem. So here it will be, let j is equal to 0, j is less than the length of the recursion result, and there you go, like this. Okay, then here you have the first recursion result or the first result of the smaller problem. Okay, now what you do on top of that is you basically consider all the positions. So do you guys remember, if I have a string, let's say in the result, smaller result, I have ABC. So where all I can add the answer, I can add once the value over here, and I can add the once value over here, here and here. So there are basically 4 positions. So based on the length of this, if the length of this is 3, right, so I will be doing these many iterations, correct? I hope it makes sense that this is nothing but value plus length plus 1, right? Why? Because we are starting with 0 and we are going up till that value. So if the length is 3, I am going 0, 1, 2, 3, 4 times. Clear? Now we go to this and we add the value at every position. So this is the character that needs to be added. This is the result we have. And this is the character that needs to be added. So what we do over here is we do val dot substring. Okay, so we take the substring from 0 to I. Okay, then we add the character in between, and then we take the rest of the substring. I'll explain this. Okay, how is it forming every position characters, and then we are just pushing that newly formed character added to this. Okay, so what is happening over here is that here, let's say initially the value of I is 0 and the smallest string result that we are considering is BC. Okay, so when I do val dot substring 0 to 0, okay, because I is 0, so that means this part is empty, it doesn't have anything, okay, in the start. Then I am adding the character, so basically A gets added, and then I am basically considering the substring from the 0th index, because val dot substring I, so I get ABC. In the second time, what happens is the value of I is 1. Okay, so what is the substring from 0 to I? It is just B. Correct? This is just from 0 to 1, the substring is B, and then we add the character, which is A, and then we add the rest of the substring, which is just C. Now the value of I becomes 2. Then what happens over here is we consider the substring from 0 to 2, which is BC. Okay, and here then we add the character CH, which is A, and then we take the rest of the substring, which is nothing. So this is how we are getting all the 3 substrings and adding A at all the positions. This is actually a very interesting way, and I would recommend spending a few more minutes to have a better understanding of how this part is working. Now let's see if this is working or not. It says I not defined. Let's see where, okay, this is J, okay, and not I. Let's see now, and there you go. You have the outputs. Clear to everyone? I hope I was helpful to help you understand this concept. Just to reiterate a little bit, we have the length of the string, which is, in case it's 0, then we simply return an empty array in the output. Okay, this is push so that we can add something over here, right? Because we are just manipulating strings, so you at least need an empty string to start with. This is where you are making a call to the smaller problem, and this is where you are doing self work. So understandably, we can see that this is the problem in which the self work is a little bit high, and we have to add characters at all positions. But with this concept, we can understand how the values are getting added and how the entire code is stitched together. Okay? All right then. Thank you for taking a look at this question, and I will see you in the next one. Bye.